So here's part two, and we left off in the last video with saying that the logarithm base 2 of 8 is 3. Because a logarithm, what is that? It's the exponent I raise the base 2 to get a given number, and so the exponent I raise 2 to get 8, that's 3. And we pulled out this other member of this fact family, and we said, well, of course the exponent you raise 2 to get 8 is 3, since 2 cubed is 8. So here's that exponent, 3, that you raise 2 to get 8. So before I get maybe overly confusing, let's do another one. So log base 10 of 10,000, well, that's just the exponent I put on 10, 10 to the what gets 10,000. Well, the exponent that I put on 10 to get 10,000, that's 4, because that's how powers of 10 really work. 10 times 10 is 100, that has 2 zeros. 10 times 10 times 10 is 1,000, that has 3 zeros. And 10 to the 4th is 10,000. And so one note here before I go on, this is called a common log. And whenever you have base 10, it's called a common log, and usually they don't even write the base. It's kind of like, square root, the index is 2. If I just put log, the base is 10. So they don't usually write the index when it's a square root. They don't usually write the base on a logarithm if the base is 10. They just say, oh, that's base 10. So let me do another one of those base 10 where I don't write it. So the logarithm of 0.1, the exponent I raise 10 to get 1/10, well, that's negative 1. Because that's what that negative exponent really means. It means vomp. It means put it down in the denominator. And so the exponent I raise 10 to get a 10th is negative 1. Maybe one more. The logarithm base 3 of 1 over 81, well, that's negative 4. Since when I start breaking this down and I go, okay, what exponent do I put on 3 to get that fraction? Well, it's a fraction, so of course it's going to be a negative exponent. And when I start playing with powers of 3, 3 times 3 is 9, times 3 is 27, times one more 3, 27 times 3, you know what, I don't know that in my head, so let me do it 2 at a time. 3 times 3 is 9, 3 times 3 is 9, put those two together, 9 times 9 is 81, 4. When I multiply 3 by itself 4 times, I get 81. So 3 to the negative 4 is vomp, 1 over 81. But this strikes me as sort of interesting, playing around with these fact families, because let's go back to where we were a second ago. We said stuff like the cube root of 8 is 2, since 2 cubed is 8. That was a fact family similar to what we did in the first video. And now we're saying the log base 2 of 8 is 3, since 2 cubed equals 8. This first one is focusing on, okay, so it's a root, and a root means what you multiply by itself the index number of times. So the 3 is given, the number of times we multiply it by itself, or in a sense the exponent here is given. The exponent 3 is given. The base is not. It's the base that you're sort of looking for. Well, what do you cube to get 8? This time the base is given, and it's the exponent we're trying to figure out. So they're very, very, very similar kinds of things. It's just what's known and what's unknown in a certain respect. So again, a fourth root of something. You're saying, all right, fourth root, something to the fourth got me 16. Some number to this given exponent got 16. Oh yeah, that must be 2. Got it. This is 2. Got it, that's 2. As opposed to the logarithm base 2 of 16. Now you're saying, all right, 2 to the something. 2 to the something equals 16. What's that something? Oh yeah, 2 to the fourth. The exponent is 4. All right, that's plenty.